Awesome. Yeah, it's got to keep reminding me because I get off on. Okay, so it's not good. I got, we're supposed to 6 first. Yeah, we'll do that. Aren't we supposed to solve quiz questions? Yeah, I'll give you on the quiz questions. Since we really didn't get a chance yet to go over 4.5 or 4.4, I'll take those. The quiz questions, I just want to make sure you have a time to work through them, and then we'll, but I'll also, if someone has a pressing question on any of the quizzes, we'll take a look at those as well. Okay. Okay, so I'm going to go ahead and I'll pull up WebAssign.
And did you recently upload the Zoom meetings from Homeworks like 14 point, I think it was 14.2, 3, and 4, something like that?
Yes.
Okay.
I did find them, and they were, so I did upload them. What I did is I uploaded them by the date of the date we had the meeting. So sometimes, like it might be under 14.4, but we were actually probably talking about 14.3 at the time. But yeah, in the Canvas, they are organized by the date of the meeting.
Okay.
Okay. I'll just give you a slight disclaimer. I don't know how fresh my mind is. I bumped my head last night, and I think I have a slight concussion. So I take no responsibility for errors, but so watch me closely, I guess is what I'm going to say. Okay, so let's read through this one. I think what I'll do with it is I'll help you get it set up with how to go about it rather than actually solving it. There is not a question like this to this extent on the test, but we'll just go ahead and go through this. So got a study of a country's colleges, universities result in a demand equation. So this is going to be important. Q equals 2,000 minus 2P, where Q is the enrollment in a public college or university. P is the average annual tuition. So P is the price. Q is the demand. Officials at a normal state university have developed a policy whereby the number of students it will accept per year at a tuition level of P dollars is given by this equation. That's how many it will admit. So let's get that. Okay. Find the equilibrium tuition price P bar and the consumer's produces. Okay. Actually, we didn't do anything with the equilibrium price, did we?
No.
We just equal and then solve for P, right? For that.
Yeah, that would make sense. Is where do these two intersect? Because this is how many they're going to accept. This is how many are demanding to get in, but they're only going to accept this many. So that would give us the p-value. So we'd want this first Q, which is the demand equation, and the second one, which is the supply equation, basically, where are they equal? I see how this is going to work.
I used the calculator for this.
Sure.
And then I found the intersection. In the intersection, that's the equilibrium price, correct?
Right, right.
Okay.
So we need to solve this equation, and it can be done by either graphing and finding what p-value gives us this intersection. Once you get that, that's what P bar is. That's the tuition price where supply and demand are equal. Okay, so once you solve this, I mean, we could do it, let's see, we would add 2P to both sides. And I guess while we're at it, subtract 7,000. So that gives us 13,000 equals 2.5P. Divide both sides by 2.5. What's that?
5,200.
5,200, thank you. And again, that's going to be our P bar. We then, so we could put that right here. And then for consumers surplus, we're going to use the demand equation. So you use.
Can we see how to do it with the calculator though?
Yeah, you just find the intersection between these two.
Yeah, no, I mean the consumer surplus part.
Oh, sure, sure. Yeah, I wouldn't do that without it. So consumer surplus, we've got Q equals 20,000 minus 2P. We're going to use P bar equals 5,200. What you'll notice though, this is one of them where we have Q equals something, not P. All the other problems, they have it already solved for P. So the first step we have to do here is solve this for P. So we would subtract, actually that's 20,000, isn't it? Yeah, one more zero.
Are you going to show us how with the calculator after this?
Well, yeah, I have to get the equation set up to put in the calculator. So yeah, so we have to solve for P first. Because remember, in our calculator, P is our Y value, so we can't enter this into the calculator until we get it solved. So minus 20,000 equals minus 2P. Divide both sides by -2. So we end up with P is equal to Q minus 20,000 over -2. We've got P bar equals 5,200. And since this is consumer surplus, what we do, we graph these two. I think we'll find that the P is on top, this is on the bottom, and we find the area between those two curves. So can you see my calculator?
Yes.
Good, okay. Got a new one. This one was a free one. It's Wabbit EMU if you want. There's a little bit of difficulties to get it downloaded. So we graphed the first one, Y minus, so I'm gonna do it this way. Q is actually our X, minus 2,000, 20,000, divided by -2. P bar is 5,200. Okay, and what we're going to do is we're going to graph this, but we need our window to be able to see everything. We know we're at 5,200. This is starting maybe at about, it's about 10,000 actually. But so our Y value, let's go to 15,000. I think we'll be able to see everything. Our X max, that's, wait, P bar, that's our Y. Our X is going to be number of students we allow. So I'm just kind of trying to guess. Let's put this at 15,000 as well. I don't know if that's necessary or not. We graph it. So this looks like this is our P. This is our P bar. What we want is we want the area between these two. So we want to do Y1 minus Y2. So we go to vars, Y vars, function, Y1 minus Y vars, function Y2. And I'm going to come over here. And the reason I switched to this one too is I think it'll a number of you don't have the color version, so you'll see the non-color version can do just as good. We'll go to the graph, and now what we see, this is Y1 minus Y2. Notice how it's really just been brought down to the x-axis, and now we're going to get the area between this curve. Let's see. What did I forget to do? There's something I forgot to do. Does anyone know what I forgot to do?
To lower and upper.
Very good. I need to find the point of intersection, which maybe we did, 5,200, but I need to find the Q value of the intersection, right? And so I'm turning off my subtraction function. Notice these are the first two. What I need to find is exactly the boundary. So it's going to go from 0 until wherever the intersection point is. So we go second calc, number 5, enter, enter, enter. Our intersection point is 9,600. So that's our Q bar, right? 9,600. Q bar.
Wait, second calc what?
Number 5.
Number 5. So second calc, number 5, find the intersection. Okay, so find the intersection of the two curves. And it gives us that it intersects at x equals 9,600. Y is 5,200, but we knew that from our work before. Okay, so that we were able to find out by hand. So now is the time we go back and we graph the subtraction of Y1 minus Y2 because we're finding the area between the two curves. So I turn off the other ones just so they don't distract us. And then I'm going to take, so what I'm finding is this is going to give me, oops, the integral from 0 to 9,600, Q minus 20,000 over -2 minus 5,200. I guess it's dq, right? Yeah. So that's what we're finding now. Second calc, we do number 7, which is the intersection function, or the integration. It asks for the lower limit. We do 0, and the upper limit, 9,600. fills into there, and it tells us, what do we got? Boom. 23 million. So there's a way to, yeah, 23,040,000. So that's what goes in as your consumer's surplus. And what that means is that,
sorry.
what's that?
Sorry, go ahead.
No, I just said that, so that what that means is that there's, at this particular price, students would actually have been willing to spend another $23 million, but so that leaves $23 million out in the student population. Okay, questions?
So would we just plug in the 9,600 in for Y2 to find the producer surplus? And do the same thing, or?
Well, actually, you would test it. You would graph the producer surplus is going to be using the 7,000 plus 0.5, and I would see if they do intersect at that same place. I would assume they do, but what you would do is basically the same steps, but we would be for producer surplus, and this is what I'm going to allow you to do, is we're doing the integral for 0 to the intersection point. And remember, we switch the order, so we do 5,200 minus, and again, this one we're going to have to solve for P as well. So it's going to be Q minus 7,000, because I bring the 7,000 over, divided by 0.5. Yeah. So that's the function. But again, what you do is you graph, so this is maybe Y2, or maybe you make this Y1, whichever you want to do. But if you make that Y2, this Y1, check where they intersect. It may very well be they're 9,600, but I don't guarantee it. It might be something different. And then, but always find where they intersect. That's what you're going to integrate towards. And then again, the steps will be the same there. And then what you do is total social gain is consumer surplus minus the producer surplus. And that's what you'll have for that one. Okay, so I think that's enough to get you started through it. Again, as it's not on the test, give the second part a try. We could maybe take a look at this later. So there was also a question on number 5. And again, these ones are like what you would see on the test. They're already set up with P equals, so we can just move forward. Let's see. I think it was question 5, right?
Yeah.
Let's see.
Yeah.
Yeah, okay. So again here, we are doing producer surplus. So we're going to want to go the integral from P bar minus P, and we'll use, instead of Q, we'll use X because that's what we'll be putting in, to the 1/3 power, which is a cube root. Okay. So we can make this one our y1, this one our y2. We will go from 0 to the point of intersection. So we're going to graph these, find the point of intersection, and then we'll do y1 minus y2 and find its integral. So these ones are kind of, and they're pretty much all like this. Let's see, here we go, we're on. So I'm going to leave my y1 minus y2. And if you weren't sure, again, you put them in and you see which one's on top. So think of this as really just doing difference between two curves. 7 plus 2x raised to the 1/3 power. Okay. I'm going to turn this one off for now so that I can find the intersection, but I'm going to change my window. Notice my y value is only going to 12 on this one. So I don't need to go quite as high as 15,000. Maybe 20 will be enough. Maybe, and my x, let's see, I'm going to guess 20. So I'm just going to, and I'm going to take a look and see if the graph, so there's the first graph coming in. Here comes the second one. Yeah, it's all good. I see the intersection point here. What we're getting is the producer surplus is going to be this little area in here, but I need to find that point of intersection. Second calc, number 5, intersect. And then I just enter, enter, enter. It gives me my intersection is 15.625, which I think is what, 7/8, not 7/8, 6/8. So 15.625. So then I come back, turn off the two equations, the two graphs, and I turn on my y1 minus y2. And what I should see is basically that same area has been now somehow moved down to the x-axis, and it kind of flips it. But this area that we were looking at now is between this curve and the x-axis. So we do second calc, number 7, which is our integration. The lower limit is 0. The upper limit, 15.625. Takes a little while, but it finds it's 19.53. And they want our answer rounded to what? Nearest cent. So 53 next to it is a 1, so it stays 19.53. And that should work. Let's test it out. While we're at it, let's test these out. Okay, we got everything. So we're doing pretty good for, I guess my brain was fresh enough. Okay, how's that? Everyone good?
Yeah, Professor Lugokro, if
Yes.
you go through 14.5, the last homework, just as an example, one integral, like the converges, diverges thing with a fraction, because I don't know, like 4 or 5, it caused a little bit of trouble.
Okay, so you, number 7 or?
It's 14.5, number 5 or 4, any
5 or
of, yeah.
either of those, okay.
Either just to see an example with fraction, because
Okay.
a little bit of problem.
Yeah, both of these basically the same. They've got
Yeah.
the 3 on top or 6 on top. Okay, gotcha. Okay.
Can't see your screen.
Here we go. Okay. Assume the fact that the limit as m goes to infinity. Let me think. It's been a while since I've done these. So what we do is we think of this as going from 1 to some m. We let the limit of m, actually, I guess it goes to m, go to infinity.
Is there a way to do it on the calculator?
Well, once we get it set up,
Gotcha.
yeah. So the first thing we have to do is we have to integrate it to see if it's going to converge or diverge. So we've got to be able to use our tests on it. So we do need to be able to integrate this. So we're going to have to rewrite this as x to the, let's do this as minus 1.5. As m goes to infinity. Again, we're going from 0 to m. So now what we integrate this by adding 1 to it, right? And then dividing by that. So this integrates into 6 over, we add 1 to this, it becomes negative 0.5. So that's what we need to divide by, negative 0.5. And this becomes x to the negative 0.5. Okay, plus a constant, but what we're going to do is actually instead of plus the constant, actually it's not 1, not 0, it's going from 1 to some m value. Okay. So this is like a negative exponent, right? Since an exponent is negative, this will converge because as x gets really big, right? It's still in the denominator. And so as x gets bigger, the limit, so I'm correct, but what we're going to do is we plug these in, okay? So we plug in m as the upper bound. So we get 6 divided by 1/2 is 12. Is that right? Actually, negative 12. And then, so we get negative 12, x to the minus 0.5, 1 to m. We plug in our limits, minus 12 m to the minus 0.5 minus 12 1 to the minus 0.5. So there's our limits. or there's our, yeah, using the integration limits. And remember, we let the limit of m go to infinity. So if m gets really, really big, this goes to this goes to 0, right? So it's going to act like 1 over infinity, which goes to 0. So on this one, if this part goes to 0, this whole thing becomes 0. And so then we just have to work out the second part. What's 1 to the minus 0.5 power? This one should be an easy one. 1, right? 1 to any power is still 1. That's why 1 is such a nice. So this part is just becomes 1 times negative 12. And then we've got a minus. So a minus and minus gives us a plus 12. So it does converge, and it converges to 12. So I guess the only way, I mean, you could plug this part into your calculator, but other than that, you have to, since we're dealing with a limit, calculators don't do limits. Okay, so this part you have to do analytically. So I would say, yes, it converges, and it converges to 12. Does that make sense?
Yeah, thank you. And with the negative infinity and the positive infinity, it's pretty much the same tactic, right?
Exactly. Yes. Yes. And then
Can you
you
move
just.
the little bubble real quick? Sorry, I was still looking
What?
at the notes.
What's that?
Can you move the screen? I'm still looking at the notes.
Sure. Sure. But let me check it first. It's always good to know that we got it right. So verification, there it is. Okay, so for these, yeah, you sort of just replace the infinity with some letter. They use m, do the integration, plug everything in, and then in the last step, you bring back the infinity by taking m, the limit as m goes to infinity, and see what happens. Now, had this been a positive 0.5, then it would have diverged, right? Because it's a square root, but it's going to infinity. That answer goes to infinity. It diverges. So what we would have done is we would have marked diverge and put on, as far as the integral itself, it would have a d and e, because it goes off to infinity. So the only time we're going to have a value is when it does converge.
Okay, I see. Thank you.
You're welcome. Since it's going to 12, let's, is there another question? What time is it? It's almost time. If there's not another question, I'm going to show you, let's see what happens if we graph the original and see if there's something that might make sense.
Could you do one more on this page after, like number 1 or 2 or 3?
Sure, sure.
Thank you.
So let's, and this might help with this. So what we're going to do, let's take this stuff out. We don't need it anymore. I'm just going to see what happens when I graph 6x to the negative 1.5 power. And even though it probably doesn't cross the x-axis, let's see, since the value is 12, let's just graph it and see what we see. Okay, so we see this, and the problem is yeah, it's going off to infinity, but it looks like there is some sort of a boundary. Okay, so actually I'm going to do zoom. I won't do that. I want to zoom in a little bit, so I'm going to go to 10. 20 is probably too high. So it looks reasonable that it's getting close enough to both of the axes that it would converge. And let's see what happens if we do second calc number 7. And let's go from 0 to some large value. Let's make it 1 million. That's 100,000. Oh. How about, let's go to 10,000. Let's see if it, still can't do it. Okay, probably because it's going to infinity. But I guess you could graph it just to see, yeah, it looks reasonable that it would converge. But that's about all we can do with the graphing part. Okay, other than that, because it's going off to infinity, you can't really do much. Okay, and you wanted to take a look at, say, 1, 2.
Yeah, any of them are good.
3. 2 should converge. 1 will diverge. So 1 should be a quick one since it does diverge.
How do you know just by looking at it, it diverges? You didn't even do any math work or anything.
Because,
Are you just a math wizard?
not really. I've just done this so many years. I've been, be a math teacher for 20 years and you start to pick up a few things. I would not call I am not a mathematician. I'm not necessarily a math wizard, but I do know a few, I spot patterns.
Gotcha. Okay, well, go ahead. Sorry.
Yes, and you'll see, I'll show you what I'm thinking. Is I looked at x and I know that the integral of x is x squared. So we'll just do this one here. So we're going from 6 to infinity.
Question?
Yes.
Integral is the same thing like antiderivative, right? Adding 1 to it?
Antiderivative, yes, exactly.
Okay.
Good. So that's the thing to keep track of is again, we're going to integrate this. So again, technically, we turn the infinity into some finite amount that we take its limit. This m goes to infinity. We add 1 to the exponent, so that gives us x squared divided by that new exponent. That's all there is to it. And then we're going to go from 6 to m. So we plug in m, so we get m squared over 2 minus 6 squared over 2. And I should always write down the limit as m goes to infinity. Again, my mathematician colleagues would be on me about that, but I know what we're going to. When m goes to infinity, you take infinity and square it. What do you get? You get infinity squared. It's so big, this part is going to diverge. So that's how I knew. So I knew we were going to end up with x squared, and I know x squared is one of those things that's going to diverge. So
if it goes to infinity or negative infinity, it diverges?
Correct, right.
Okay, thanks.
And then this is a fixed amount, but you subtract a little bit from infinity, you're still at infinity. Okay, so this one diverges is all we got to mark. And then here we put D and E. This one I can see is going to converge because of the negative exponent. I think this one as well, because of the negative exponent, they both will converge. So again, we could just take a look at one of them. So the integral from 0 to infinity, e to the minus x dx. Again, technically what we're thinking is we're going from 0 to some fixed point, but then we let that fixed point go to infinity. So just remember, when we integrate e to the minus x, that is e to the minus x over the constant in front. And again, we go from the limits. We can write this a little nicer just as minus e to the minus x, going from 0 to m. So we plug in our limits, minus e to the minus m. minus, this is why it's important because we are going to, will converge. We subtract when we plug in 0, so that's minus e to the minus 0. Okay, as m goes to infinity, since it's a negative exponent, what we really have is we have e down here in the denominator, right? It's getting really big, but it's dividing into 1. This part goes to 0. Okay, so you just have to know those limits. So that's why I said this takes in really everything we've learned. We just know that we have to know that this limit goes to 0. So our answer, and then e to the minus 0, anything to the 0 power is 1. So this would be minus 1 with the negative, negative, negative makes it a plus 1. So our final answer is, yes, it converges, and it converges to 1. And we'll test that out just to be sure. So converges to 1, submit it for testing, and we're good. I think this one's, well, because it goes to -2, it's going to be similar. It's just when it integrates, it's going to integrate to minus 0.5x divided by -0.5. Okay. But the big part is if you've got this negative exponent, when the exponent goes to infinity, yes, this part goes to 0, so it converges. Okay, how are we doing?
That makes sense. I just have one quick question on the last question of this homework assignment.
Okay.
So for the integral on this one, would your values be like on the bottom? Would it be 0 and then 5 on the top?
Suppose the revenue from sales of new homes in a certain country decreased dramatically from 2005 to 10, as shown where T is the year since. If this trend were to have continued, if it were to end it, 2005. No, so you're going to go from 0 because 2005 is year 0, and we're going to pretend that what this is saying from 0 to 5 is saying the data is only from 0 is good for the 5 years, and so we know that's all it is. But whenever they ask us to go into the indefinite future, that's the part that becomes infinity.
Okay.
So yeah, so we'll go from 0 to infinity on this one. And again, it's an e to a negative, so it will converge. So it'll be very similar to this part as far as your integral. This front part will go to 0 because it's got a negative exponent. And the back part where you plug in the 0, it'll become e to the 0. That part will become 1. And I'm just going to guess that the answer is going to be 416, I think, because I think this, just from this, the numbers would be different, but the front part, even with different numbers, the front part will go to 0. This back part is basically, oh wait, it's not quite. Let me show you how I can tell. It's going to be 416 divided by this negative 0.31 or 326. And remember, since it's in the back side, it had a negative in front, so a negative is going to make it positive. Let's see if we can just kind of, so what, does anyone have what 416 divided by 0.326 is? If you could plug that in for me.
Okay, it says 1,276.
1,276.
And then it's 0.07.
0.07. They want it rounded to the nearest billion. This is in billions, so it would round to 1276. 0.07. Okay, let's see. I think, now if I'm wrong, that's, wow, I got it right. So in the end, it was a 416 divided by this because, so after you work, and that's, the question was, how do I know? You work a lot of problems and you start to see certain patterns. but again, I don't expect you guys to get there. This has been 20 years of working problems, and they paid me to do it. I wouldn't do it if I wasn't paid. So is that good? Take
Yeah,
us
that's
forward.
perfect. Thank you.
Okay, so, and again, what I'll do is, since we didn't spend much time on the quiz, I will come up with sort of some review notes of how to approach each of the units as we go. I'll work on fitting in some videos on some of them as well, so you can watch those. But then again, if you have questions, go ahead and email me with the questions. And I can make sure I make either some videos on them, or we'll address them in the next class. And be thinking, I think we could have a study session either Monday. I have to give a final for my 117, but Wednesday might be a good day, and we could even do a little bit longer session because I don't have their meeting. So we could like meet at 9:30, 9 o'clock or something. So send me some of your preferences, maybe for Wednesday, then that's the day right before the test to go over any last minute things that you might have. So we'll keep that open as an open offer, and just keep making the progress. Send me questions. We're in the study mode now. And if anything does close down, my intention is to have everything available and workable and getting points on. So like homework assignments in this, at least in this last section, I can extend things which I think I have, but if anything becomes unavailable, feel free to email me and just let me know. I'll extend them further if needed. Okay. So if there's nothing more.
Thank you, Professor. Have a good day.
Thank you. You too.
Thank you.
Take care,
Yeah,
everyone.
have a good day.
You too.